So we want to take a look at determining whether or not a triangle is a right triangle. This is also known as the converse of the Pythagorean theorem. So what we do know is that the Pythagorean theorem states that if we have a right triangle, then a squared plus b squared equals c squared. So this is if we have a right triangle, right? So essentially, the converse of the Pythagorean theorem simply states that if this is not true, if a squared plus b squared, let's fix that, does not equal c squared, then this is not a right triangle, right? So in order for it to be a right triangle, it has to be equal. Every other triangle will not satisfy the conditions of the Pythagorean theorem. So that's why we call it kind of the converse of the Pythagorean theorem. So all that we're going to do to determine if a triangle is right or not is we're going to substitute the three sides into the Pythagorean theorem. Okay. If we get a true statement, then it is right. If it's not true, then it is not right, a right triangle, right? So one thing you want to do is you do want to make sure to just estimate your sides as a decimal first, because some of them are going to be in radicals, and we need to make sure that we're plugging into the Pythagorean theorem correctly, which means that C is our hypotenuse. So we just need to double check this. So the square root of 91 is approximately 9.5. So in this triangle, I can determine that my C value is the 10 centimeters. So it's very important to make sure that your C value is your longest side. And if they're in radical form, we can't be sure about that until we look at a decimal approximation. So we're just going to substitute this into the Pythagorean theorem. So 3 squared plus the square root of 91 squared equals 10 squared. 3 squared is 9. Square root of 91 squared is 91. 10 squared is 100. 9 plus 91 is 100. 100 equals 100. So the Pythagorean theorem holds true here. So yes, this is in fact a right triangle. We can just say, yep, it is. All right, so we're going to do the same thing here. So 2 times the square root of 5 is approximately 4.47. This is where we need to be very careful. So that is our C. So in this case, this is going to be our C. We're not going to use the decimal approximation when we're plugging into the Pythagorean theorem because that's just an approximation. We're going to use the actual radical value. So here we have 4 squared plus 3 squared equals 2 times the square root of 5 squared. Now do be careful when squaring this because you do need to square those two pieces separately. We're going to square 2, then we're going to square the square root of 5 separately. So we're going to get 16 plus 9 equals 2 squared is 4 times square root of 5 squared is 5. So we get 25, 16 plus 9 equals 4 times 5 is 20. So that is not true. Those are not equal. So we can say, no, this is not going to be a right triangle. So our first one did end up being a right triangle. But this one, when we plugged it into the Pythagorean theorem, we got a statement that was not true. So no, it is not. Okay, so we can do this even if we don't have the sides on a triangle. That doesn't really matter. We just need to get those decimal approximations to determine what is our hypotenuse. So 2 root 10 inches is approximately 6.3. So that's going to be our C value. And remember, A and B, because we're adding them and addition is commutative, doesn't matter which one we make A and which one we make B. So we're going to have 4 squared plus 5 squared equals 2 times the square root of 10 squared. Okay. So let's see, that's 16 plus 25. And then that is going to be 4 times 10. So we're going to end up with 41 equals 40. That is not true. So this is not a right triangle. Let's do one more. So we want these decimal approximations because we need to determine who's our hypotenuse. So we need to approximate all of these real quick. So let's see, 2 root 11 is about 6.6. 3 root 6 is about 7.3. 7 root 2 is about 9.9. So if we're looking for our C value, that's our longest side. That's the 7 root 2. So let's apply the Pythagorean theorem and see if it holds. So 2 times the square root of 11 squared plus 3 times the square root of 6 squared. And then that we want that to perhaps equal 7 times the square root of 2 squared. All right, so we're going to get 4 times 11 plus 9 times 6 equals 49 times 2. So we're going to get 98 equals 98. There we go, which is true. So yes, this is a right triangle.